Now, there may be multiple sets that we try to depict within one universal set, and they can overlap or they can be separate, or one can be contained in the other. So here's a drawing where we have our universal set. We have a set A and we have a set B. This also has a universal set, a set A and a set B. And so does this one. But each one of these Venn diagrams depicts a different relationship between set A and set B. In the diagram on the left, set A is contained in set B. So the way that we say that is A is a subset of B. In that case, the set A is completely contained within the set B. The notation for that we saw in that little video in the last class. Remember, contained in starts with a C, and we use an elongated C to show that one set is contained in the other. We have the line underneath that to show that it's possible that the two sets are actually equal. So this is the symbol for a subset. Anything that's contained in or possibly equal to the other set is a subset. So A is a subset of B is written in this way. With that in mind, let's fill in the blank with a subset symbol or a not a subset symbol to make a true statement. So looking at part A, guys, which one do you think is true? Is it a subset or not a subset? You tell me what to write. You say not a subset. Why is it not a subset? Well, let's just draw a picture just to make it clear. You're right, it is definitely not a subset. One is not contained in the other. For example, this element C, well, actually I take that back. It's not C. C is in the other subset, is in the other set, I should say. It's B that's the problem child here. So the element B is not actually in the other set. So ABC is not contained in ACD. So we would have to say that this is not a subset. Now, notice the direction here matters. It's just like the less than and greater than symbols that we use. So for example, it would be true to say that 4 is less than 5, but it would be false to say that 5, well, let me turn it the other way, hold on. It would be false to say that 4 is greater than 5. Right? That wouldn't be true. What they are telling us to do is to determine if the set on the left is contained in the set on the right. So actually, the fact that D is not in the set on the left is not an issue because it's possible for this set. For example, I could have had the set A, B, C, D, and then ABC would have been a subset, right? It would have been okay that D, this extra letter, was in there as long as the set on the left had only elements that were in the other set. This would be true. Okay, so it's not the D that's the problem. The problem is the B, that the set on the right doesn't have the B in it. Okay, so how about, well, let me draw, before we move on to part B, let me draw a little picture of what we just saw. So if we were to draw, if this is, let's call the set ABC, we'll call it capital A, and the set ACD, we'll call it capital B. So I'm going to draw a picture, a Venn diagram of set A and set B. And here's my universal set U, whatever that is. All right, so A contains A, B, and C. And B contains A, C, and D. So they both contain the elements A and C. but A contains the element B, and B contains the element D. So neither one is a subset of the other. In other words, there's no way we could draw the picture like A inside of B, which is what we're wanting if it's a subset, because A contains this element B, and where would we write it? We can't write it outside of A. So if we have one circle inside the other, there's no place to put B. So B is the problem there. Okay, so now let's look at the set 1, 2, 3 and the set 1, 2, 3, 4. Do I write a subset or not a subset? Yes, it is a subset because 1 is an element of the set on the right, 2 is an element of the set on the right, and 3 is an element of the set on the right. So this set 1, 2, 3 is contained in the set 1, 2, 3, 4. All right, so you could actually draw, I'm going to draw it two different ways just so you can see that when we draw Venn diagrams, we have a variety of options. When you know nothing about the relationship between the two sets, it's, and let me give them different names. Let's call this set D, C, and D. Okay, so when you know nothing about the relationship between the two sets, when it's possible that they overlap, they don't overlap, that one's contained in the other or one's not contained in the other, it's safe to draw the Venn diagram like this. You'll always have a place to put everything. So for example here, 1, 2, and 3 need to go into C, and 1, 2, 3, and 4 need to go into D, which means that 1, 2, and 3 are in both C and D, so they're in the middle part here. So actually, I need to make that bigger because I just don't even have room. Not exactly circles, but that way I can fit 1, 2, and 3 in here, okay? And then 4 would go in the region that's only part of D over here. So we have a place to put everything. Okay, but that's not the only way that one could have been drawn. Notice there's no elements of C that aren't in the overlapping part with D. That's because C is a subset of D. So another person might have drawn them in this way, putting C, which has 1, 2, and 3 in it, and then putting D, a bigger set that C is contained in, with only that extra 4 outside. So these would be both perfectly valid Venn diagrams. Okay, since the C is completely contained in the D, C is a subset of D, which is why I put that subset symbol there. Okay, another thing we talked about in class last time was that two sets are equal if they contain exactly the same. Oh, I see a question. Would question B be considered a proper subset? Yes. Let's go back to that slide. So we had mentioned in class last time that there's also something called a proper subset. The subset symbol actually includes two possibilities. Contained, one set's contained in the other, and then that little line underneath includes the possibility that the two sets are actually equal. If you know that a subset is not equal to the overall set because there's at least one element they don't have in common, or sorry, I shouldn't say it that way, there's at least one element more in the bigger set, then you could use the symbol that just means contained in and not equal to. Oops, my pen is freaking. Okay, so this symbol on the top, this is the symbol for a subset. This is less specific. It means contained in or equal to. And this symbol down here is the symbol for what's called a proper subset. and that just emphasizes that it's not equal to. There's no equality allowed. So the question is in part B, could you write proper subset rather than subset? And the answer is yes, because this set is bigger. It has an extra element in it. Good question. Okay, let's go on now. And we're going to talk about an alternative definition to having two sets be equal. So we learned before that two sets are equal if they have exactly the same elements. And another way of looking at it is if you have two sets A and B and you want to know if they're equal, check to see if A is a subset of B. In other words, if every element of A is contained in B. And then check to see if B is contained in A. Every element of B is an element of A. If both of these things are true, then it must be that they have exactly the same elements, so they're equal. All right. A proper subset, as we were just discussing, just means that it's a subset, but it's not equal. All right, so there's going to be problems in your homework where you're asked, and on your tests, where you're asked to decide if it's a subset, a proper subset, or both. And I want you to think of the analogy to the less than or equal to and the less than. So all that line under the subset symbol means is or equal to. Okay? All right, so notice that in this problem, we have only 3 options for what they want us to fill in the blank. Equal to is not one of them. So we have to decide which of these applies. So in part A, we have ABC and we have ABCD. So to determine if you have a subset, you check to see if A, B, and C are all in the other set. And here we have all of them, A, B, and C. So it's definitely a subset. Okay, remember subset is the symbol with the or equal to. It's contained in or equal to. In part A, would it be true to say that it's also a proper subset or not? So remember, in order to be a subset and a proper subset, it has to be contained in but not equal to. So what do you think? Is it also a proper subset? Yeah, it's both a subset and a proper subset because the D means that these two are not equal. Okay? All right, so very good. So the answer would be both. Both a subset and a proper subset. How about part B? First, is it a subset? So is the 1 in here? Yes. Is the 2 in here? Yes. Is the 3 in here? Yes. Is the 4 in here? Yes. This is a subset. Okay, is it a proper subset, part B? No, that's right. It's not a proper subset because it's equal to. And you can't have a proper subset if the two sets are equal. So the only one that would work would be the subset symbol. Okay? Subset includes the possibility of equal to. We could use equals, but remember that wasn't an option. So you can even think of the proper subset as this. Okay? Proper subset means it's contained in, but it's not equal to. Now, notice that if you have a proper subset, that it has to be a subset, but not the other way around. In other words, if you have a subset, it's not necessarily a proper subset because it could be equal to. So when you're asked if a set is a proper subset of another set, there are really 2 conditions that you have to consider. First, are all of the elements of the set in the other set? If so, then you definitely have a subset. If not, then the set is neither a subset nor a proper subset, and you can stop. Then you have to check if the set is a subset, you have to ask yourself, are the two sets equal? If they are equal, then the set is a subset of itself, but it's not a proper subset. But if they're not equal, then it's both a subset and a proper subset of the other set. So you try this. Determine whether bold N is a subset of bold W, a proper subset of bold W, both or neither. All right, so first we have to remember from our first class, what did the boldface N represent? What set of numbers did the boldface N represent? Anyone remember? What was that set called? It starts with an N. That's where it gets its symbol from. Good, the natural numbers. The natural numbers are given that nickname because they're the ones that we first learn to count when we're kids. They appear visually in nature, right? We can count objects, 1, 2, 3, and so on. And then what was the extra number that the whole numbers, the one denoted by a W, has in it that the natural numbers don't? There's only one extra number that the whole numbers have that the natural numbers don't. Very good, 0. So remember, it took a long time for humans to conceive of 0 because you can't see the quantity 0. So in that sense, it wasn't natural to us. So when we add that to the set, we give it the nickname, the whole numbers. All right, so now what are we being asked? We're being asked whether N is a subset of W. I'm going to write these down in symbols. So N being a subset of W would look like this. Whether N is a proper subset of W. Okay. Or both or neither. All right, so let's look at subset. So in order to be a subset, that means that the set is contained, the natural numbers would be contained in W and possibly equal to W. So if you look at the set of natural numbers, it starts with the number 1, which is in W, 2, which is in W, 3, which is in W, and it continues on in that way. So it would be true to say that the natural numbers are a subset of the whole numbers, yes? But is the set of natural numbers, is it a proper subset of the whole numbers? So the only way it would not be a proper subset is if it's actually equal. So I'm just going to write down, is the set of natural numbers actually equal to the set of whole numbers? Another way of answering this question is there an element of the whole numbers which is not in the natural numbers? Because if there is, then they're definitely not equal, right? Yeah, that's right. It's a proper subset. It's not equal, and it's because of the number 0. So because we have the number 0 there, that's in the whole numbers but not in the natural numbers, then we know that the two sets cannot be equal. And if they're not equal, then it is true to say that it is a proper subset. It's true that it's a subset, but it's also true that it's a proper subset. So that means the answer here is both. Okay? Okay, next topic is we're going to count how many subsets there are of a given set.